Hi, welcome you all once again. Here we are going to discuss about SortedSET interface which is going to be implemented by TreeSet class. Here the SortedSET interface is extending the set interface which is providing total ordering of its stored elements. The elements of the SortedSET are arranged in increasing order, that is ascending order, using built-in comparator method. The built-in comparator method will compare each and every element by using that order. Then it will store in sorting order in the form of ascending order. The sorted set provides the additional methods that inhibit the natural ordering of the stored elements in TreeSet structure. Here the sorted set can be instantiated by using the TreeSet class. Here the set is the object variable which is created by using TreeSet class to implement the SortedSET interface. The data type has to be given here by using generic data type with the wrapper class. Here the navigable set is also there, that is also can be implemented by using TreeSet class. The navigable set extends the SortedSET interface. Here when we are instantiating the set object variable, automatically the default structure implicitly the binary tree will be created here. So the tree set is using the binary set tree concept implicitly, and also the nodes are self balancing automatically. Here the level of the nodes in the tree will be balanced by itself to give that balanced tree approach. The tree set implements sorted set and navigable set interfaces. Both are using the tree set storage for storing its elements, and also here the tree set will store only the unique elements by using the set concept like hash set class. However, the accessibility and retrieval time of the tree set elements quite fast when comparing to hash set class. Here the objects of tree set will be stored in ascending order based upon the nature of sorted set interface. Here the tree set will not allow null elements in the structure, and tree set is non-synchronized. That means when the thread is accessing the elements from the set structure, another thread will be in the waiting queue. It cannot access parallelly. That is available in the TreeSet class. Here the TreeSet can be instantiated with the default constructor. Here it is creating empty tree that will store the elements in ascending order based upon the sorted set interface. So here the set object variable is created by using TreeSet class. Here we have to mention the wrapper class data type, and the constructor is not carrying any elements here, which is implementing the sorted set interface. Likewise, we can instantiate the variable here to implement the set interface. Here we can use the collections, right? Already we will have some collection like array list or linked list or vector or class, stack class, or hash set, or another one tree set. Any collection can have some elements. Here those elements will be passing as a argument in the tree set class, right? Then tree set is carrying those elements and copying into the variable which is created by using the TreeSet class, which is implementing the set interface. And likewise here the external comparator we can use. In the previous slide we have seen the sorted set interface will use built-in comparator method to sort the elements which are going to store in the structure of TreeSet class. But we can use external comparator method, that is user defined comparator method, by passing the value through this argument. So here we are passing the comparator argument, and TreeSet is instantiating new object to implement the set interface here. And another one approach here, we can copy any one of the shorted set interface values to the TreeSet class, which is creating new variables to implement the interface. So here the TreeSet, which is having some elements, right, that is transferring from the shorted set class. That means copying from the shorted set, the object variable is here, yes. So like this we can use the TreeSet to implement the set interface in different approaches. Here we will see the example to copy all the elements from collections, any one of the collections. So here I am using the class name treeEX1 and main method. Then here I am using the array list as one of the collection, here Java collections. Then for this array list I am going to instantiate the variable AL, which is going to carry the integer elements to implement the array list interface, right? Sorry, list interface. Here list interface is implementing, and when you are instantiating AL, this array list structure will be created. Then I am adding elements one by one, first 10, then 4, then 1 and 25. So 4 elements stored in the object AL, which is representing the array list. Now just I am printing the elements of array list here. After that, here I am going to copy all the elements available in the AL to the TreeSet. The TreeSet is created as a name of tree1 by using TreeSet class, which is implementing the shorted set interface by using integer elements. So for this TreeSet, I created tree1. For the tree1, I am copying all the elements of array list here to implement the shorted set interface. After that, just I am printing. Okay, once you are copying this, automatically you see the elements which are available in the array list copying to the tree structure here. Okay, 10 will be passing here, and 4 is less than the 10, then 1 is less than the 4, then here 25 is greater than the 10. So based upon the binary tree data structure, here one collection elements are copying into another collection element. Then I am printing the values of TreeSet here. So you see the array list we are printing in this statement what we have inserted: 10, 4, 1, 25, 0th index, first index, second index, third index. After that we are printing the content of the tree set 1. So here tree set contains 1, 4, 10, 25. You see we have inserted 10, 4, 1, 25, but when you are printing in the TreeSet, which is ordering the elements in ascending order by built-in comparator here, so the elements are sorted in ascending order. This is the way to copy all the elements from one collection to TreeSet structure. And another one example I am giving here to add and access the elements from the tree structure, I mean a TreeSet class structure. Here I am giving the class name, then main method, then TreeSet is created with string data type. Here the variable is T, which is implementing the set interface. Once it is created, then this tree structure will be instantiated with the name of T. Then I am using scanner class to receive the inputs during the runtime. Here I am entering the number of inputs. Then I am getting the input from the user as 3, and here the n value is 3. Now enter the string as a input because the string data type is used to instantiate the variable. Then here n value is 3, so 3 strings one by one we will receive. Here first I value is 1 less than or equal to 3, then which is entering into the for loop. Here I am receiving first input, that is TreeSet, then which is going to be add into the tree t. So here we are going to add this value here in the tree set. Okay, tree set, that value is stored in the node. Then I is compared here, I less than I is incremented, then I will be 2, 2 less than 3 compared, then which is entering into the for loop, which is receiving the value, second value is whoop, that will be stored in the tree structure. Then again I is incremented, 3 less than 3, which is true, again inside getting inside the for loop, then which is receiving third input, that is java, that is going to be added into the tree structure t variable. Then now we are going to increment the value of the I 4 less than 3, which is false, then automatically come out of the for loop. Once it is come out of the for loop, then I am printing the tree set 1 contains the values which are stored in the variable t, right? So t is having 3 values, right? But it will be sorted in the alphabetical order, because sorted set interface is storing the values in ascending order. Then I am using the iterator method to access the elements from TreeSet class. So TreeSet structure is having these 3 elements, and these 3 elements are copying into the itr variable, which is created by using iterator class, and TreeSet is accessing by using the iterator method. Here iterator class is having one method has next, just it will check the values which are available or not. Then it will print first element is java, which is printing here. Then it is checking another element is exist, I mean it is moving to another element, then which is checking another element is it is available or not. Yes, it is available, whoop, then it is printing the whoop, then moving to the next element, right? The next element is also here available, then it is giving true here, then which is printing the current element tree set, then which is moving next. So now there is no element, so it is null, so it will become false, then it will come out of the loop. So in between that, this statement is giving space between each and every term which is stored in the tree structure. Okay, so through this we can add elements one by one by using add method. We can access the elements by using iterator method one by one by using hash next for checking the elements. To move from one element to another element, we can use the next method of iterator class. Thanks for watching.